Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from functional equations involving the derivatives, right? And here we have a very interesting problem, and here we'll make use of the famous L'Hopital's rule to get the solution of this problem, right? So let us start. So here we have the problem, that is if f prime of x is differentiable and f double prime of x is continuous at x is equal to 0, and the value of the second derivative of fx at x is equal to 0 is m, then we have to find the value of this limit in terms of m, right? So this is going to be a very nice problem, right? So here we have to find the value of this limit in terms of m, right? So let us call this limit as, say, L, right? So L is limit x tends to 0, and we have 2 times f of x minus 3 times f of 2x plus f of 4x divided by x square, right? So now here comes the role of L'Hopital's rule, right? So L'Hopital's rule says that if we have limit x tends to 0 and we have two functions, say h of x and g of x, then this limit is equal to limit x tends to 0, and we differentiate this function h of x, that is h prime of x, and we find the derivative of g of x, that is g prime of x. So this limit is equal to this limit, provided that h of 0 is equal to 0 and g of 0 is also equal to 0, right? So for applying the L'Hopital's rule, we must have the quotient, that is 0 by 0 form, right? So we'll apply this rule to this limit. So now let us take this numerator as h of x, right? So let us take h of x as 2fx, then minus 3 f of 2x, and then we have f of 4x, right? So if we take x is equal to 0 here, then h of 0 becomes 2 times f of 0 minus 3 times f of 0, because 2 times 0 is 0, 4 times 0 is 0, so we have here 0. So this is 2 plus 1, because here the coefficient is 1, so 2 plus 1, 3. So we have 3 f of 0 minus 3 f of 0 is equal to 0, right? And let us take the denominator as g of x. So this is x square, right? So g of 0 is 0 square, that is 0, right? So we can get the form that is 0 by 0. So we can apply the L'Hopital's rule, and in the next step, immediate next step, we'll differentiate the numerator and the denominators separately with respect to x. So now we have the second step, limit x tends to 0. The derivative of f of x is f prime of x. Then we have minus 3 f prime of 2x, and then by chain rule the derivative of 2x is 2, right? And here we have f prime of 4x, and then by chain rule we have the derivative of 4x as 4, and in the denominator we have the derivative of x square as 2x, right? So here it is important to note that the derivative of f of 2x, see here we have f of 2x, so the derivative is f prime of 2x, then we differentiate 2x with respect to x, so we get here the derivative of x is 1, so we are left with 2, so we have 2 f prime of 2x, right? And similar is the case with f of 4x. So when we differentiate f of 4x, then we get f prime of 4x, and then the derivative of 4x, the derivative of x is 1, we are left with 4, and this is 4 times f prime of 4x, right? Okay, so now we have this expression, limit x tends to 0, we have 2 times f prime of x minus, this is 2 3s are 6, so we have f prime of 2x, and here we have 4 times f prime of 4x divided by 2x, right? Now cancelling the factor 2 in the numerator and denominator, we get limit x tends to 0, so we have f prime of x minus 3 f prime of 2x, and then we have 2 f prime of 4x divided by x, right? Okay, so now we have this limit, right? Now let us once again apply the L'Hopital's rule to this limit, right? So what we have limit x tends to 0, and we'll differentiate the numerator and denominator separately with respect to x. So now the derivative of f prime of x is f double prime of x. Then we have minus 3. The derivative of f prime of 2x is f double prime 2x, and then the chain rule applies here. We have 2, then here we have 2, and the derivative of f prime of 4x, f double prime 4x, and here we have by chain rule the factor 4, right? And in the denominator, the derivative of this x is 1. So now we have limit x tends to 0, we have f double prime of x, then we have 3 2s are 6, 6 f double prime of 2x, then we have 4 2s are 8, and then we have f double prime of 4x, right? And here we have now got rid of this denominator, right? Okay, so now if we take the limit, that is x tends to 0, we have f double prime of 0. So substituting x is equal to 0 in this expression, we have minus 6 f double prime of 0, because when x is 0, 2 times 0 is 0, and here we have f double prime of 0, because when x is 0, then 4 times 0 is 0. So viewers, we have got this limit, right? And see, here we are given that f of double prime of f at x is equal to 0 is m, right? So we are given this value. So we'll substitute this value in this expression. We have m, then we have minus 6m, then we have here 8m, right? Because the value of the second derivative of f at x is equal to 0 is given as m. So we have m minus 6m is minus 5m, then this is 8m, and this is equal to 3m, right? So viewers, the value of this limit is equal to 3 times of m, right? Or we can also say that this is 3 times the value of the second derivative of fx at x is equal to 0, right?